They landed on opposite sides of Mars in 2004, and they drove 30 miles combined. And they both found evidence that there had been water on Mars in the past. But we still weren't sure whether that water fostered an environment that was good for life. And so then we sent Curiosity in 2012. The Curiosity Rover was big, it had a big robotic arm, it had a drill, it had a science lab in the front. And Curiosity was trying to understand the habitability of Mars. Could Mars have ever fostered life? Could life have ever grown on Mars? And within months of Curiosity landing on the surface, she actually found an ancient habitable environment on Mars. But we still don't know if life ever did form on Mars, and that's the goal of the Perseverance mission.
Wow. Thanks, Jennifer. And now that we understand how each rover mission helps shape the other, let's get to know Perseverance.
Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
Perseverance Rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater.
To the Kennedy Space Center in Florida, where our next Mars rover will be propelled into space by an Atlas V rocket. And the man who leads the company tasked with safely getting Perseverance off this planet is Tory Bruno. He is the CEO. You get a little nervous. Why do you get nervous?
Well, a rocket is such an incredibly powerful and complex machine. Everything has to go right. Nothing can go wrong. And it's just, it never gets old. It's always the same.
It's always exciting.
Yes.
And this is a particularly exciting mission. Talk a little bit about that. This is the largest and heaviest rover that we've ever sent to the red planet. So how did you configure your rocket to do this launch effectively?
Yeah, this is our second most powerful Atlas, the 541. We call it the Dominator. It's got 4 giant SRBs, each putting out 350,000 pounds of thrust to augment the center core. And so it has got the power to get out there to Mars, as well as the precision. It's the most accurate rocket in the world, because when we let it go, it's got about 200 million miles to travel on that transfer orbit.
And precision is key.
That is right, yes. So the power source for the Mars rover is a contained radioactive battery. I've seen it up close, and we had to alter the way we behaved around that.
Yes.
How has that changed your team's efforts?
Oh, yes, the operations around that are completely different. Now, we have a lot of experience with these. We've flown all of America's RTGs, and we're the only provider that is certified to handle them. But, it is still 11 pounds of plutonium, as you saw.
Yeah.
And in this particular case, the one very special thing was to install it in the VIF, where we would normally never breach the containment around the spacecraft because it has to be clean and biological free. But we created a portable clean room and brought this nuclear battery out and installed it in the machine while keeping everything perfect.
Awesome. Can you explain what the VIF is actually before I let that go?
The VIF is the Vertical Integration Facility. So these rockets are so gigantic. We build them in a factory, but we can't assemble them there.
Yeah.
Atlas and Perseverance are standing 20. Which we did, but then we opened it to install the MMRTG battery.
Yes.
And that came late in the process, and that was intentional.
Yes.
You mentioned there's a certification. Who certifies the rocket?
So NASA certifies the rocket, and then NASA and the Department of Energy certify a provider like us to handle a nuclear payload because of all these special requirements.
Very good. When you were preparing for this mission, you couldn't have imagined a year ago that you would have a coronavirus pandemic wreaking havoc on this state. How did you handle that, and how did you overcome it?
Yes, well, the one big lesson learned here is you can't buy back time. So when this broke out, our response was early, it was aggressive, and fortunately it was effective. So we did all the things you might be familiar with. We wipe down every surface every hour, we deep clean every evening, we are wearing PPE, we have our teams spread out, we actually change the
Hello everyone, this is Rifat here. I'm the lead scientist and Chief Technology Officer of Space Kids India. We are so happy and excited to connect with you guys on the occasion of Perseverance launch. It's really going to be a historic mission. So myself and Clinton Anthony, our propulsion engineer, will be joining us today for the live session with you guys. So let me share the screen of the launch and we will be discussing. Hi, Clinton. Your audio is not audible. You're not audible, Clinton.
Hi, bro.
Hi, Clinton. How are you?
Few of the teams involved this morning. We want to start with the U.S. Space Force. They're responsible for the range operations and weather.
Am I audible, bro?
So, Mick, tell me about the range really fast before we get this weather
COVID's
briefing in just a few seconds.
Yes, the United States Space Force is responsible for public and personnel safety here at Cape Canaveral Air Force Station and Kennedy Space Center, where we're launching from. So, a very important part of the mission today. They are one of 5 teams that are working with us to launch.
Yeah, I can hear you
this morning. And an important part of that, not only public safety, but is they also do weather for us to make sure that everything looks good. As we saw that sunrise this morning come up right behind, everything is looking good. So.
Mercy?
Hello.
I think your internet is slow.
Roger.
So yeah, guys, Clinton's audio feed is, I think, not good. I think due to the slow internet. Let's wait for a moment. Clinton, I can hear you, Clinton.
Sorry, we thought we were going to get that for you live, and apparently the audio is on another channel. Forgive us.
You should be looking at a visible satellite image. We have.
So yeah, guys. Today it's going to be a historic day. It's just T-minus 29 minutes for the historic launch of the Perseverance. So yeah, Perseverance is almost similar to Curiosity, as we all know. But the main difference is, it's having much better hardware, much better cameras. Like it's having around 18 cameras all around it. It has a mic for the first time. I think we are going to. I think first in history we are going to listen audio from the other planet, and we have oxygen production. Oxygen producing experiments on board, and we have Ingenuity Mars helicopter. So this is and we also have the RTG for powering up the rover. Clinton, I think your feed is much better now. Can you able to see and listen to me?
Yeah. Am I audible?
Yeah, you are audible. You're audible, Clinton. So how excited are you and how's the things going?
I told it last launch itself. So we have traffic in Mars transfer orbit this month. Though the 2020 is a very challenging year for people, 2020 is very good for space, I guess so. We had three. We are going to have third Mars mission, and we had a comet Neowise and everything. So in space and astronomy wise, it's a spectacular year.
Yeah, that is true. That is true, Clinton. It would be great if you can give us an overview about the Atlas rocket and today's launch configuration.
Okay, so Atlas ULA. I will start with some basic questions, frequently asked questions. Even I too had the same questions, and I got searched in the internet and I got those answers. So why ULA for all the exploration, Mars exploration mission? Why United Launch Alliance for all the Mars exploration missions? So this is the common question all the people used to ask, because we have SpaceX, we have other organizations, private organizations and people, but all the Mars missions are launched by ULA. So why? Because first of all, Atlas is a very reliable rocket. I guess so. More than 80 launches it has completed successfully. Only one, that too, it's a partial failure. So from the reliability point of view, it is a great vehicle. Secondly, it is not the new thing for ULA. ULA already did the Mars transfer orbit for more than 10 times, I guess so. This is the third mission for Atlas 5. If we started now, we had Curiosity, Maven, Insight, and now Perseverance. We have Perseverance. So all the Mars exploration flagship missions are launched by the same configuration, same Atlas vehicle. And likewise, all the launch vehicle have the launch vehicle code, and today's launch vehicle Atlas is also having launch vehicle code. First of all, let me start from the beginning. Atlas is a expandable launch system again. So we already found this thing in the last live, I guess so. All the rocket experts expect Falcon Heavy and Falcon 9 or comes under the expandable launch system. And Atlas, today our Atlas 5 configuration code is 541. So we have a 3-digit configuration code. The first digit 5 stands for the fairing diameter of a 5-meter fairing diameter. Sorry, given a wonderful explanation why that we are going with the 5-meter diameter fairing for a smaller Perseverance. And the second digit stands for the number of solid rocket boosters strap-ons attached to it. So today's launch will be having 4 strap-ons, and the third digit stands for the number of engines in the Santa upper stage. So we'll be having single engine Santa upper stage. So we'll talk about details about these things in the later stage.
Yeah.
Yeah,
So
these
the
are
God Bless America
warm.
song is playing, I guess.
The beautiful baritone voice of Grammy Award-winning singer Gregory Porter. That was outstanding.
It was so emotional. Ah,
If
really
I could
great.
launch the rocket right now after that, see some rockets ready
Do you
to
see where they are sitting? Actually, they are sitting at the place where people usually go and watch the launch.
to unlock many
Due to the
mysteries about
lockdown,
Mars, but
they
remote
didn't allow any
scientific
people
research
to go
can only go
there
so far.
and
Joining us now to talk
you know
about returning Mars samples back to Earth
watch the
is
launch in
Dr.
live.
Lori
So
Glaze,
these
Director
guys
of
put the
NASA's
table there and
Planetary
they are
Science
talking from
Division.
that
Thank you
location.
so much for joining us
You
today.
can see that the launch countdown
First,
that
can you
image
talk
in
to
the
us about the
background.
value of studying Mars samples here on Earth?
Tarun G is asking,
Now it is a
what are
digital
those
copy.
towers standing around the launch pad? Because I saw them during Tianwen 1 launch day.
And part of the reason
Yeah,
for that is, or the main
that is
reason
a
is,
good question, Tarun. Yeah, not just the Tianwen launch. If you have a look at PSLV launch, GSLV launch, or any launch in the world, those towers will be there. Those are the assisting towers around the launch pad. Those are actually lightning arresters. Usually rockets go and sit in the launch pad for a few days, even before the launch window opens. Many times, it rains and thunderstorms comes, lightning strikes happens. So to protect the rocket and the payload inside, they put that towers around it, which acts as lightning arresters.
The Faraday cage.
So Clinton, give a give an overview about the Centaur upper stage and how important it is in this kind of critical missions.
Yeah. So second stage of the Atlas is a Santa upper stage, and it has it's a very pride and it has lot of heritage. The second stage, the Santa upper stage has lot of heritage because it's being used from the ICBM. Like the entire Atlas cycle is derived from an ICBM, but Santa upper stage has even more things to add. Why? Because it is using the most efficient engine, that is RL-10, which is manufactured by Rocket Dynatype. So it uses Rocket RL-10C engine as a engine for a Santa upper stage. Common Santa, there are the two configurations. The Santa upper stage has two configurations. One configuration is used to have two engines, and another thing is a single engine configuration. The single engine configuration used two RL-10C. Nowadays it is using RL-10C engine. Initially it had RL-10A and RL-10B, and now they increased so many things, so made many changes, and now it is using RL-10C engine. Uh, Apart from that, Centaur upper stage is the most efficient one, right? So it has a capability to perform all the trans maneuvers. Trans maneuver in the sense like Mars transfer orbit. It can put payloads of very heavy payloads into the Mars transfer orbit. It is a very efficient upper stage. And secondly, the most interesting part of the Santa upper stage is it is a pressure stabilized tank. It has a pressure stabilized tank. Like, how I will explain this thing. Okay, normally if you wanted to put something on the top of a column or something, you need the structure. It should have that much a material or a isobaric kind of structure in order to withstand the active load which is acting on the top. But if we are going in that way, what happens is we need more material, and in aerospace, the aerospace industry doesn't want any material to be added because it in turn increases the weight, right? So what the engineers did is they used a balloon type of. If you are familiar with Scott Manley's video, he will be explaining very clearly. Balloon type of tank. What it does is it is a very light one, but once if it is pressurized by the fuel and oxidizer, which is liquid hydrogen and liquid oxygen, it will be more stronger. So it can handle the actual load which is acting on the top, like the Perseverance or any other payload. It can easily take the load. But once if it is depressurized, it cannot handle that much of load. So that is one of the main things. So because of this pressure stabilized the tanks are like very thin and they are very lightweight. So all these things add up and it increases the burn time of the engine, which is if the standard upper stage will be not fired for a continuously it will be not fired, it will be fired for a duration as arbitration maneuver or from passing orbit to other transfer orbits, like Hohmann transfer and other things we will be using, we will not fire the center upper stage continuously. So if in the case if we fire the center upper stage continuously, now it has the capability, it has a burn duration up to 840 seconds in this. So these are the main advantages of Santa upper stage, and it is still being used. And the next Santa, the Santa upper stage is being used in Atlas V5, Atlas 5 is Santa upper stage 3, and ULA's next mission, that is Vulcan rocket, is going to use Santa 5. That is in the development phase. So once if it is completed, and that is going to be the most efficient upper stage. So these are the specifications.
Yeah,
and
Clinton, yeah. In this time, we cannot forget about the Titan rockets, right? So, Titan rockets are like predecessors to the Atlas. So, what do you think about the Titan rocket?
Hello?
Can you able to hear me?
Yeah, bro, but not properly.
Yeah, I was telling that, like the Titan rocket is the predecessor to the Atlas rocket. So what do you think about the Titan rocket?
Titan, it's an ICBM. So it's being used. ICBM is intercontinental ballistic missile. Like you're familiar with intercontinental ballistic missiles. What it does is it carries a payload in a ballistic trajectory, and like payload in the sense nuclear warhead, and it is straight away pointed. If it was a American ICBM, it will be directly pointed towards the Russia, and if it is a Russian one, it will be pointed towards the vice versa. So that is how it's the main not only Atlas, but all the rockets is being used in olden days by NASA are like derived from ICBM. Even Atlas is from the Titan family. So Titan are the very capable ICBM. It has multiple independent multiple targeting vehicles also with it. So it's very complex. I don't want to get into the ICBM stuff. We'll use space for peace, not for weapons.
Yeah. That is cool, Clinton. So other thing is today we are going to fly the Ingenuity rover. It is going to be one of the most important milestones we are taking in exploring other planets. So how important it is going to be, and what is so different in the Ingenuity rover? Because Ingenuity helicopter, because it just weighs around 1.2 kilograms.
Okay. So Ingenuity is not a scientific experiment or anything. It is a technology demonstrator which is going to demonstrate the powered flight in other planets. So why we need a power flight capability in other planets? Why? Because if you know the speed of Curiosity and Perseverance, then you need a flying kind of mechanism in order to move fast, because Curiosity moves 5 centimeters per second. So it is a very 5 centimeters per minute, I guess. So it's a very slow movement. If you wanted to explore the Mars, it is going to take centuries with that speed. So once if we have this type of power flying capabilities, if we have if a JPL can design a bigger rover, it flies and it hops from place to place, it will be very easy. And they don't want it to land in the exact position, so they can land wherever they want. They can hop from place to place, and it increases the from the mission point of view, you can do more things with the this type of like it is very agile, right? So it gives more scientific data and everything. So that is the reason why we are going with the powered flight system. Powered flight is like even the deployment mechanism of the Perseverance Rover, which is going to use sky crane maneuver. If you can, if you can play that video now, it will be great. The sky crane maneuver, the audience is to see. So the sky crane is nothing but if you wanted to land on Mars, like there is a maneuver called EDL, which is entry descent landing. So for that landing, what they are using is a sky crane kind of thing, and they will hang the rover at the bottom, and they will place the rover, and the crane will go away. So even that is a powered flight, but it uses rockets. But Ingenuity is going to use wings for flying, like a conventional helicopter and a conventional aerodynamical thing. It is going to fly. So that is more important. And second thing is that MOXIE, that Mars Oxygen Institute resource utilization experiment. That is also a very good idea, and I think it is from MIT, I guess so, bro. So what is your point of view? I don't know much about MOXIE, so like I wanted to hear from you.
Yeah, MOXIE is such a cool experiment. Normally this hydrogen fuel cells are that, right? It is based on the principle, but doing it in the reverse process. So when you give the hydrogen and oxygen and fuse it together, the water will come out. So what they are planning is CO2, carbon dioxide, right? So they are planning to separate oxygen from CO. If you can do electrolysis, not electrolysis. I forgot the name. Forgot the processing.
No.
If you can do that, you can tap the oxygen molecule out of the CO2. So you can get CO and O separately. So that oxygen can be used for breathing, and also the same oxygen can be super chilled to make oxidizer for the return trips. That is the reason, methane also can be produced in the Martian, surface. That is why Raptor engine, because the goal of the Raptor engine is to take people back from the Mars. So that is the reason they are putting the how to say. I don't know. It's rolling. I think the audio I'm listening. One second. Yeah, they are doing this no go. Let's listen to that. Okay, that is going to be a very legendary thing, right? Let me patch that audio.
Yeah.
When I saw the country shutting down, I thought for sure there is no way we're going to be able to continue this.
It's something that nobody expected. It's something that nobody can plan for.
Rather than your first priority being mission success and getting to the launch pad, your first priority immediately gets displaced, and it's now the safety of the people.
I was seriously thinking Mars would be Mars 2022.
It took a lot of work to put stuff together in order to keep momentum going, to keep people working safely, keep them healthy, and to keep the project on schedule.
There's no doubt that working in isolation, not virtual isolation, but in physical isolation from everyone else, is a challenge.
It's hard for me. I have 2 young kids. Sometimes I'm not able to focus or listen probably as well as
it's just even 10 minutes
a lot of our work
for the launch.
That meant even before we entered the clean room, we had to find ways of ensuring that
I think the but over. Let me rewind it a little bit.
For the spacecraft customer is incredibly important. So usually we're able to be here working beside them.
I'll just rewind it so we can listen to it.
It's now the safety of the people.
Time.
We are about to hear from workers at centers in California and Florida who took every imaginable precaution while managing to get this vital work done.
When I saw the country shutting down, I thought for sure
to count down towards that 7:50 a.m. liftoff time.
Yeah, that's exactly right. Procedure. So, team is very focused this morning. As you already mentioned, the earthquake that was brought up. The team has
himself, Omar Baez. He's going to pull his team for right on time here in just a few seconds. Let's listen in now.
This is the NLM on the NLM net. Currently working, no issues on the range or the launch vehicle. Weather is green, 10% chance of violation, and winds aloft look good for the entire window. The spacecraft did experience some earthquake activity at their control center in Pasadena, but appears to be ready to proceed. And with that, I would like to poll the team for final launch poll and spacecraft configuration. NASA CE.
NASA CE is go.
SMA.
SMA is go.
SMD.
SMD is go.
NASA Mission Manager.
NASA Mission Manager is go.
LSP.
LSP is go.
Copy. NASA team is ready to proceed.
All right, we heard NASA team is ready to proceed. He even mentioned the weather in there, which is great, only a 10% chance of violation. Again, a big thank you to Jessica Williams of the U.S. Space Force, 45th Space Wing.
I like the fact that we're working no issues this morning into this count. That's an important part that Omar brought up. And the team, one thing you need to understand about the NLM is it's a combined NASA team of spacecraft and engineering. So hearing all those goes is good this morning.
Yep, and we're going to keep moving because we got a lot to do still. We're going to throw it back out to you, Daryl.
All right, thank you very much, Joshua. Our NASA teams across the country overcame challenges caused by the COVID-19 outbreak, as you've heard so far.
School in Burke, Virginia, submitted the winning essay to name our rover Perseverance.
Yeah, they've got a great view. I've seen it from up there. They've got the VAB in the background.
Team in 7 minutes.
Set up for this awesome launch. And Vanessa, you can see her. And waving. Hey, guys, appreciate you. She's a junior at Tuscaloosa County High School in Northport, Alabama. She entered the contest as well and came up with the name Ingenuity, our helicopter.
This is going to be awesome.
Thank you both for being here. What a neat view that is.
Yes.
All right, folks, with the coast phase coming up, we want to let you know that after the launch, it will be about an hour before Mars Perseverance separates from the second stage. When that happens, the rover will then be on its way to Mars. So hang in there.
Yeah, don't go away as we will walk you through the flight around the Earth, and we'll talk live with the astronaut Zena Cardman about our human exploration ambitions and NASA's Associate Administrator of Science, Dr. Thomas Zerbuchen.
It's going to be great, folks, so stick around. It's L-6 minutes and 26 seconds now, and time to focus our attention on the launch operation the rest of the way to liftoff. So let's send it back out to Mick Woltman and Joshua Santorin. Gentlemen.
Thank you. I want to let you
It's just T-minus 6 minutes now.
Let's go to that now.
Range coordinator. Clear to proceed. Launch director. LD is go, and you have permission to launch. Proceeding with the count. ALC, verify T0 is set for 1150 Zulu.
So 11:50 Zulu.
It's T-minus 5 minutes 45 seconds.
As I'm watching Josh do the calculations on his finger.
Get my advocates out.
That's right.
No, so there's a lot to come ahead. One of the things coming up in just a few seconds.
5 minutes, 30 seconds.
OS,
NSC.
Go NSC.
Spacecraft on internal power and timer set for T0 of 1150 Zulu.
Roger. OS, start list data capture.
Roger.
Fantastic.
All steps are complete prior to terminal count. LC switch is ready.
Awesome. So things are really starting to pick up here. You're going to hear more and more chatter on those nets there. That call was to say that Perseverance is powered and ready to go, which is a phenomenal call.
Yeah, a couple things happened during that time, right? Is launch conductor, ULA's launch conductor, Scott Barney, pulled the whole ULA team. They were all go. We got to hear
the third of our 5 teams.
The third of our 5 teams. We got to hear the end of that where the range was clear to proceed. And ULA's launch director, Bill Cullen, gave the authority to go for launch this morning at 7:50 a.m. Then we got to hear from the JPL spacecraft team that they are
the fourth team,
that they are on internal power and timers are set. They are targeting a liftoff of 7:50 a.m. this morning. So all things are looking good for us, Joshua, this morning. It's so, we talk about being nervous and excited. This
It's
is
just
right here where we're
5 minutes.
Yes. There are a lot of things happening as we get ready to count down to the liftoff this morning. We have about 15 seconds left in this hold before we pick up the count.
Yeah, we're going to listen into that. The fifth team, the one we haven't mentioned yet, is the Department of Energy, who is responsible
mark,
for the
time will be
MMRTG, the power
4
source
minutes
for
and counting.
Perseverance.
3, 2, 1, mark.
Awesome. So this is now the terminal countdown. This is that time when things become more and more automated over the next few minutes, and the energy's building, but the focus is increasing exponentially.
Yeah, as Tori said during his interview, you know, the teams are very disciplined, very focused on what they're doing, the operational sequence of events that they're following. They are making sure everything happens, especially in this T-4 and counting period, because there's a lot of things they have to do. They have to finish topping the vehicle, make sure that all the tanks, first
This is
stage,
going to
second
be
stage,
awesome.
flight pressures and full of fuel, ready to go for this flight. They have to make sure the FTS system is armed and ready for personnel safety, just in case, so the range can do that. They have to check the electrical and avionics systems. They have to make sure that the flight computer has all the information it needs to place Mars 2020 into the orbit it has to. So a lot of things going on. Exciting time for the team right now. But again, staying focused and following that procedure they've got.
As we look ahead to post liftoff, I want to kind of preview for you what's going to happen, because there's going to be a lot going on. You're not going to hear much from us. You'll actually be hearing from the ULA flight commentator, Jesse Gonzalez. He'll be kind of giving those calls past liftoff that will walk us through maximum dynamic pressure and into SRB separation, and then into fairing separation, booster separation, and then the first main engine ignition of the Centaur,
yes.
RL-10. And so then you'll kind of hear us jump back in and help provide some more context to what's going on. We encourage you to stay with us for the rest of the show, though. There's a ton more content we have to bring you, and we are far from over. I want to emphasize that the countdown to Mars is not done at 0 today. The countdown to Mars ends in February, when Mars 2020 safely delivers Perseverance and Ingenuity to the surface of the red planet. So we're going to let you listen in now and enjoy the last couple minutes of the process of launching a rocket.
One minute 59.
Vehicle internal.
1 minute 55.
Launch sequencer start.
1 minute 50.
Securing Centaur Link 2. Securing Centaur LO2.
So there we heard the fueling is
1
wrapping
minute
up.
40.
Yep, fueling is wrapping
Launch
up.
enabled.
Team is done. Launch enable's
137.
done. Launch conductor sequence is ready to go. They're getting ready to turn the vehicle over to auto
Yep, just
sequence at T-minus 31 seconds. So that's a big thing that they're getting done here. At T-minus 25 seconds, we will hear the team give their final goes that everything is ready and
1
the
minute
launch
20.
vehicle is ready to lift off and
OCU
perform
armed.
this mission.
SCS count
1
started.
minute 15.
Produce ECS for launch. Roger.
1 minute 10.
Lock.
1 minute.
Rock, report range status.
Range green.
That's good to hear, Joshua, right
That's
there.
public safety there is accounted for, the FTS system. There you see on your screen a beautiful shot. The skies look great. There's little wind happening. You'd be able to see more of the venting. If there were wind, the trail of that venting. So we're ready to go.
And actually, that's an important point. The reason we don't see that
Stable
venting
at
is the
step 3.
vent valves have been locked up to put flight pressure into the tanks. And as we just heard, they're stable at step 3, which means the tanks are ready to go. And here at about 5 seconds, we will
28
hear
seconds.
the team
ECS reduced for launch.
give their final go.
25 seconds.
Status check. Go Atlas. Go Centaur. Go Mars 2020.
There we go. We are ready to get lift off this morning, Joshua.
Wow, T-minus 10.
7, 6, 5, 4. Engine ignition. 2, 1, 0. Release and liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the red planet.
Wow.
Successful liftoff.
And Atlas
Go
TU
for
is on his way.
Go Centaur. Powerful dialogue.
Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1 Atlas 5 is now supersonic. And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure. And passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout. And we have burnout on all 4 SRBs. Burnout pressure signatures look good. Standing by for SRB jettison shortly.
Hey, awesome.
And we have a good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance. Vehicle pod rates are responding normally at this time. And coming up on 2.5 minutes into flight, the RD-180 is down slightly as expected. Engine response continues to look good. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour. And the Centaur reaction control system is now pressurizing to flight levels. And just past 3 minutes into flight, the RD-180 is now throttling to maintain a constant 2.5 G acceleration limit for payload fairing jettison. Engine response and vehicle acceleration look good. And we have good indication of payload fairing jettison and Centaur forward load reactor deck jettison.
So these are the 5-meter fairing.
The RD-180 is throttling back up to attain a 4.6 G acceleration. Engine response continues to look good. And Centaur has begun the boost phase chill down sequence to thermally condition the RL-10 for operation. Standing by for ECO shortly.
Bico is the booster.
And we have Bico, booster engine cutoff, standing by for stage separation. And we have good indication of Atlas Centaur separation. And we have F1, RL-10 operating parameters are good. Chamber pressures are stable.
Though RL-10 is a expander cycle engine, in order to start it, you need a gas generator kind of thing. So that is why the small came from the design of it. Gas generator engine, but in order to start, you need a gas generator for that.
So Mick, that's pretty exceptional footage there. That's live video. We will see that switch over shortly into an animation that kind of helps let us know what's happening with the rocket. But right there, a beautiful liftoff. Fun to feel that rumble in the building here as we proceed towards orbit and then towards...
beautiful launch, Clinton, right? It was very beautiful.
Perfect.
So I think
5 seconds. Josh, you and I worked the InSight mission, and if you recall, that mission on the West Coast took about 17 seconds to get past tower. So with those 4 solids today,
I think they will be doing 2 more burns now.
As we hear from Jesse, everything
To put it in the trans Mars injection.
within the design limits, and we're getting ready to and start that Jesse was talking about.
Clinton, your audio is too good. Sorry, too low. Your audio is too low.
Preparations, fuelings, powering up, all the way through that liftoff that happened.
Can you change to some other headphone or something? It's having some kind of issues.
Yeah, dead on. This team does a great job. As I said, they're very focused, very disciplined. As Tori also said, courageous. They have done a lot of work to get us to this point today through this pandemic, changed how they did some of their work, made adjustments as needed, a lot of cleaning, a lot of things, a lot of wearing their masks.
I can hear you, but it's like too far in there, and there is a delay between your video and audio.
It's worked this mission and for the country and the agency. So this is exciting.
Yeah, we had a really quiet countdown today, which is phenomenal, that we got off the ground on time. And we are proceeding now that we are in the middle of the first burn. It's tough to make out, but that engine is lit and it's firing. So we are in motion. There you go. There's that animation we talked about.
The telemetry there as we switch to a TDRS compatible data format.
TDRS
overall telemetry quality is very good.
The space tracking system. So there you go. This is not an actual video, but this is an animation that's driven by real data. So although we're not actually seeing the engine on screen right now, we can see that the engine is lit, and that is driven by the data that says that the engine is truly lit and we're in this burn.
Yeah, the launch vehicle continues to send telemetry to the launch team via the TDRS network, as you mentioned, and that allows them to continue to watch what's going on and make sure all their sequence of events meet their timeline. We continue on a nominal flight this morning. This first burn, as we heard earlier, will be about 6 minutes.
How's the audio now?
Park orbit around Earth, allow us to get on our way and get into that approximately 30-minute coast period that we're going to have.
8 minutes into flight, beginning to see the Centaur PU system balance out mass errors. Seeing very stable body rates in the Centaur.
So we've mentioned 5 teams at play, and although if you were watching, hopefully you got a chance to see this in person, if not on camera, it's easy to kind of say, oh, it's over, like job done, but all 5 of these teams still very much engaged, still very much focused, because there's a lot of as we proceed through this first burn, and then a coast phase, like you mentioned, Mick, and then a second burn, and then spacecraft separation and the acquisition of signal from Mars 2020. So a lot more coming up here. Mick, I know for Launch Services Program, you guys manage the launch. So what does that mean? I mean, this is you guys' work in action right now.
By the way, that's the 5th team that we didn't get to mention. We talked about JPL, we talked about DOE, we talked about United States Space Force, and United Launch Alliance. LSP, we are like the brokers to select this launch vehicle and help with manage this mission. So we get our spacecraft customer, the JPL folks, they come to us. They have some certain requirements that they need for this mission. The Launch Services Program made up of engineers and flight analysis folks, and they look at everything, they help define those requirements, and then we go out and procure a vehicle from a commercial partner. In this case, it was the Atlas 541 for the Mars 2020 mission that was needed for performance, right? As you and I have talked over the last several days, Josh, one of the things that was important for us to look at was that performance, to be able to get Mars 2020 onto that transfer orbit into solar orbit to intercept Mars in 7 months. It's kind of analogous to a football game, right? With a quarterback trying to throw a pass downfield. You need a quarterback with a lot of performance who can get that ball down there where it needs to be.
So yeah, guys, the rocket is on the way to the Mars now. I mean, it is on the trajectory, and soon they will finish the final burn between the trans-Mars injection. It will take 1 more hour to finish all the maneuvers. So since our team is working on the other missions and we have some work, so we are leading the stream. The stream will be available. You can watch it till the ejection, till the spacecraft separation, and we will connect with you guys. The panel, we people will connect you guys with the upcoming videos. We have some videos scheduled for next week regarding space exploration, CubeSats, etc. Keep checking our Facebook page and Twitter page. We'll be updating the. You can subscribe to the channel, our channel. Click the bell button so whenever we post a new video, you can get to know that. Thank you, Clinton. Thank you so much. I guess today's network was a little bit bad, so we weren't able to talk that much. But let's hope in the future, we'll be able to do a video together about other missions. So right now we will leave the stream, and the stream will just continue from the original. Okay, Clinton. Bye.
Bye. Thank you, bro.
Bye. Thank you. So bye, guys. The stream will be on. You can keep watching. Thank you, guys. Thank you so much. Bye.
Coast period. That coast period will allow us to coast around into the position that we need so that we can have that second firing to get the velocity needed to head off into Mars.
Yes, and we will be back for that second burn in just under 30 minutes now. But for now, there's more to learn about this mission and all the amazing science that's involved. Daryl, back to you.
Mm-hmm.
All right. Thank you very much. Great launch and great job, guys. Back outside now to recap. An Atlas V rocket carrying Mars Perseverance Rover launched on time from the Cape Canaveral Air Force Station at 7:50 a.m. Eastern Daylight Time.
Incredible. After the rocket took flight, it separated from the first stage and was then boosted into orbit by the Centaur's second stage. Perseverance is now preparing for a second burn that will put it on a trajectory toward Mars. That's just incredible to say. It gives me goosebumps.
It really is. And we're so excited about that as well. And while we wait for that second burn, hang in there with us because we got a lot of exciting coverage to go. We're going to welcome in one of our launch guests, Dr. Derek Muller. He is the creator and host of the popular science education channel on YouTube called Veritasium. He also holds a doctorate in physics education, so he's really smart. And that's why you saw us kind of having some fun because Derek was here on set. We're just having a good time talking about this launch, which I got to start off with that, Derek. Your first time seeing a launch in person, what'd you think?
I mean, what can you say? I have nothing to compare it to, but it was awesome, something I will never forget, and I definitely want to be invited back. So if you guys could make that happen, I mean, just so amazing.
You do a great job explaining physics. What did it feel like? Kind of walk me through as you were watching and experiencing it.
Well, it's like all the physics goes out the window a little bit. It's a very visceral moment between you and this very powerful craft. I think it's just amazing all the engineering that goes into making something that's that powerful and yet that controlled,
Yeah.
And to witness that is phenomenal. And then to feel the rumble of all that sound as it hits you, I found it an incredibly emotional experience. It's almost unbelievable to, see it taking off. It's very surreal. That's for sure.
Nice. What excites you the most about the Perseverance Rover?
Well, the Perseverance Rover is going to do a lot of great science. So I'm excited, for example, that it's going to cache samples that we're going to bring back. Super excited that we're actually going to have samples from Mars in our hands. And I think that may clinch whether we can see that life is actually there. But I'm also super excited about Ingenuity, about the helicopter, which I got to visit out at JPL before it was strapped to the underbelly of the rover. And to think about flying a rotorcraft in, another world, essentially, in a place that only has 1/100th of the Earth's atmosphere, it seems audacious, and I am impressed and amazed, and I can't wait to see if it works. I'm cautiously optimistic. I think the team is phenomenal.
And you did, in fact, a YouTube story on it, a piece on your channel, and did a fantastic job going to JPL.
I did, yeah, and I was just so lucky that it was like there, a meter or two away from me on the other side of a door in a clean room, and that was, one of the great moments of my life. Yeah,
that thing's going to Mars.
Exactly. Yeah, and it weighs like about as much as my laptop.
Yeah.
And you think about, it's substantial in its size, and it's going to go there and take off and fly all by itself because, of course, we can't control it given the time delay and everything. I just think one of the pinnacles of human engineering.
Yes, absolutely. Now, this is going to do some big science as well. What are your thoughts on the search for ancient microbial life on another planet, Mars?
Well, I think chances are good that Mars once harbored life. It was so similar to Earth in the past. One can only expect, life probably sprung up there as well. But I'm really excited for us to get that confirmation, because I think it really transforms our ideas about life and how frequent it is. Right now, all we have is this sample size of one Earth with life. If we find another one, that's 100% more information and data, and I think it's likely that life will not be exactly like ours. And I think it'll be fascinating, everything we can learn about other potential forms of life just by finding life on another planet.
You seem to suggest that you think there is life.
I do. I mean, you have liquid water for, I don't know how many, half a billion or a billion years. On Earth, that was enough to create life. So, the guess is that's not.
On lab like Christina. We'll get a closer look behind the scenes at the facility she's in a moment. But first, let's go to you, Jessica. Jessica Clark, fault protection engineer. Let's start with that. Let's unpack that a little bit. What is fault protection?
Yeah, thank you, Stephanie. So fault protection is kind of a unique field at JPL. And the metaphor that I sometimes hear people use is that we're kind of like the doctors for the rover. So because there's nobody to take care of the rover on Mars or en route to Mars if it encounters an issue, we actually have to equip Perseverance with the ability to diagnose problems on itself. So we build in all of this software to help Perseverance detect if something has gone wrong. And then there actually are several spare components that she can use and swap to if she encounters an issue. So in addition to that, we kind of operate like the doctors in operations once she's on her way to Mars, because we, if there is a problem, Perseverance notifies the team on the ground, and then we work to try to diagnose what's going on and try to get her back to full operations.
Now you're at home right now. You'll be on console at JPL tomorrow. What will you be doing?
Hopefully not getting too nervous, but really just getting excited. And our team is going to be looking at the data coming from Perseverance and assessing whether everything looks nominal, both before the launch and then after we launch. Once we launch, we'll actually have about 45 minutes or so before we go into what's called an eclipse. So we'll go behind the Earth and the sun will be blocked out. And during that time, we will separate from the rocket. And so that period of time we'll actually lose data, lose visibility. And then when we come out of that eclipse, we will begin receiving data from Perseverance's own radio. So that'll be a huge event where we're looking forward to seeing data for the first time being transmitted by Perseverance on its own radio.
I can't wait to see what the shot looks like out of mission control, although you'll all be social distancing, so maybe not quite as many high fives, right?
Correct. Yeah, we actually have had to do a lot to kind of work in this new realm with COVID. So we have very strict cleaning guidelines when we come into our console. We're all going to be wearing masks, so you won't really be able to see us smiling ear to ear. And then, you know, our typical jumping up and down in high fives, you probably won't see us doing that. And we are going to try to eat peanuts, which is a good luck tradition, but we will be doing it in a very discreet and safer way, but still want to try to carry that tradition through.
Fantastic. All right, so I've got a million questions, but that pales in comparison to the number of questions who are coming in from people online, and I want to make sure we get as many as possible. So over on Twitter, Fragile Fern has a software question for you. So speaking as a software developer, she's curious, what programming language do you use to control various functions on the rover?
That is a really good question. So I actually don't write the software, but we do what we call specify it for our software engineers to go and write the code, and it's all in C. So you might be familiar with that. And yeah, it's there's no special JPL language that we use.
Excellent, excellent. Now I'm just scanning through here. Let's see, cameras. May I ask you a question about the cameras?
Sure.
All right, so here we go. Amal on Twitter wants to know, how will Perseverance clean its cameras? What if dust particles cover it?
That's a really good question. So I'm not quite as familiar with the cameras, but I do know when we land, we're worried about dust accumulation from landing itself. So the cameras are equipped with dust covers that then once all that dust has settled and we've been on the surface safely, we pop them off. If after that fact, there is some dust accumulation, I don't think there's that much we can do other than kind of rely on the ambient winds to clean them off. But I know on MSL, you know, which has been on the surface of Mars for years now, we haven't had any major issues with dust accumulation. So I think we're kind of hoping for the same thing.
All right. And, you know, a lot of folks want to know, you know, how do you even get a job like this? What was the path that you took to get to JPL?
Yeah, it's kind of a winding and seemingly random path. You can't major in fault protection engineering in college. So I you know, realized I wanted to be an engineer around when I was a senior in high school. And I applied to Georgia Tech. I switched majors 2 times. I went from undecided to biomedical. I thought I wanted to be a real doctor, then realized that wasn't for me. So I went into aerospace engineering and just happened to kind of fall in love with it. And through that, I got internships at JPL. And that was a great way to kind of get acquainted with JPL and how NASA works. So through that, I got hired at JPL. And then fault protection, again, was something I had never had prior experience in, but I actually completely love doing fault protection engineering, and I don't know if I'll ever kind of switch out of it.
Fantastic. Okay, so I want to make sure that we get to all of our panelists here. So Jessica, hang on. We're going to switch things over to the Jet Propulsion Laboratory, where Cristina Hernandez is in a very, very special place, one of our indoor Mars yards. Cristina, tell us more about the lab you're in and what's going on there.
Yeah, so thanks for having me. So right now I'm in the flight software test bed. So it's basically an indoor Mars yard. And we do have COVID protocol, but I took my mask off, my Mars 2020 issued mask, since nobody else is around right now. But basically behind me, what you have is the start of the twin that will eventually become Mars Perseverance's twin. And what we do in here is we test the higher level behaviors of this robotic geologist and astrobiologist. So behind me, we've got the robotic arm in the stowed configuration. At the very top, we have the turret. And on the turret, we'll have Sherlock. We have Sherlock on the other side. And on Tuesday, the Pixel EM sensor assembly, one of our other science instruments, will be getting installed for some robotic arm testing. And so we test, all kinds of things. We take images with the instruments. We look at rocks, we drill rocks, and we try and test the end-to-end behavior that we're going to see once we get to Mars.
Fantastic. Now, I know that you are an instrument engineer currently working on Pixel. What does an instrument engineer do?
It's a fun job. Sometimes it's a little chaotic, but I think that's why we all became engineers, to solve tough problems. So instrument engineers, their job is to understand the rover and how it interacts with the instruments, but at the same time, understand all the nuts and bolts and behaviors and quirks, as we call them, of the 7 different science instruments. So we have a team of instrument engineers who have been apart from the early design and accommodation of the instruments on the rover through assembly, test, and launch operations, where we were testing with the flight vehicle and with engineers like Jessica on console. And then now we're getting ready to prepare for our operations and understanding what are the tools that scientists like Joby, that you'll hear from later, are going to need to do cool science on Mars.
Okay, so question from our YouTube chat. Laxmi Pandit wants to know, how was the rover built? So please.
It's just such an exciting question, because this is not the effort of a few engineers. It's the effort of not just the United States, but our global collaborators in France, Norway, and Spain, and many other places. So basically, we had different groups of teams build the boxes, the instruments, the different subsystems. Most of it was built here at JPL. And at JPL is where we integrated and assembled it all together. And so it started from a paper design about 10 years ago, and now it's manifested to a 1-ton beast of a thing that's on a launch pad today.
Fantastic. Oh my goodness, we're getting so many questions here from all over the world. Fantastic. All right, I'm seeing several here where multiple of you are going to be able to weigh in. And so I'm going to wait and hold those for a few minutes in the show here and switch things over to Joby. Thank you, Christina. We'll be back with you in just a moment. Now, Joby Brazel-Hollis, astrobiologist, postdoctoral scholar working on the Sherlock instrument. Let's talk about what all of that means. What is astrobiology?
So astrobiology is basically the study, mostly theoretical at the moment, of what life could be beyond Earth. So the question of, like, if life existed on a world like Mars, what did it look like? Was it made from the same molecules of like DNA that we are, or was it made from something completely different? So a lot of this is kind of like investigating the kinds of molecules that might be available on other worlds and trying to work out, well, how would they fit together? What would you expect to see billions of years later? How would life survive in such an extremely different environment like that of Mars, or, for example, another world like Europa? Now, obviously, we have only discovered life on one planet so far, Earth. So a lot of this is quite like investigative. Like we're still not sure what we're looking for, but we're pretty certain that when we find it, we'll know.
So Eduardo over on Facebook has a question for you. You mentioned looking for molecules and possibly new molecules there on Mars. He wants to know, is it possible to find a new chemical element on Mars or another compound that might not exist on Earth?
So in terms of elements, those are pretty well established. We've discovered pretty much all of the sort of naturally occurring elements that form through stellar fusion or supernovae, that sort of thing. So that's kind of everything up to iron and beyond. The super heavy elements that are still being discovered these days are being made in particle accelerators. So they're not really something we would expect to find like naturally occurring on the surface of a planet like Mars. When it comes to chemicals and molecules, there's a huge number, like almost infinite number of possible combinations, atoms that can make molecules. Now, some of them are unstable, and we would not expect to find them. The ones that make up us, so we comprise of DNA that has 4 distinct nucleobases in it. So those are A, C, G, and T. that you might remember from biology classes at school. Now, it's quite possible that alien life might have something similar to DNA that just uses a slightly different set of molecules. So, you add a methyl group there, you put a nitrogen somewhere else, and suddenly it's a slightly different molecule, which means it may not be compatible with us, but it could still be a valid way of building like an information storage system like DNA, something that could be passed on and from one organism to the next. So we don't really know what to expect. We're sort of working from what we know on Earth. So we're looking for stuff like DNA first. We have certain ideas about life needs to be somewhat complicated to be able to do clever things like metabolize and reproduce. That involves a lot of quite clever chemical machinery. That requires a certain minimum amount of complexity. So we're looking at lots of different molecules put together in a way that we have not yet observed in any of the studies we've done of organic molecules from things like meteorites, samples of Mars that have crashed on Earth from hundreds of millions of years ago. We found organic molecules, but they're all extremely simple, stuff that could have just formed through natural geochemistry, so like the chemistry of rocks. So they could be the building blocks of life, but they are not proof of life.
Now, on that note, Keisha over on Facebook wants
We are back here at the Kennedy Space Center with our most special guest, Mu, and the Perseverance Rover. Here it is, a full-scale mock-up of the actual rover itself. Well, Mu, here it is. Yes. And so we've learned a lot about this rover so far. So tell me, kind of describe from top to bottom what we're working here. At the top, you've got the Mast Cam, which is pretty tall, right?
It is very
it's
tall.
towering over your head. It is on a stage, but what does it do?
Yeah, so it has a lot of fun components. Some of them are the Mast Cam Z. Z stands for zoom. So you see those two stereo cameras. And there's also that eyeball, what looks like an eye, is actually a laser. It shoots at the rocks.
A laser.
A laser, lasers. And then depending on the signature that comes back, the spectrometer reads it and tells you what the geology is.
And that's fantastic.
Yeah.
Some of the real exciting science, though, is happening right here on this part. This is the articulating arm that comes out, right, and then goes down onto the planet and starts drilling.
Exactly.
What all is here that's going to help us understand more about the geology of Mars, the climate, and whether or not there was life?
Yeah, there's of course Pixel and Sherlock, the really amazing instruments that are going to tell us about the biosignatures. But in the middle, there is the coring drill. The real drill will have a drill bit, a coring bit, which is hollow in the middle. And there's going to be a tube inside. This is just a 3D printed version. And as it's collecting samples, it's going to have samples that go directly into the tube.
Oh, you've got a tube there. Yeah, so
there's
show
a
that camera
3D
there.
printed tube here. And it's going to go down the middle of the tube as it's acquiring the sample. Once it's done, it's going to dock with the bit carousel here. It's going to ingest the entire bit with the tube inside and the sample. It's going to rotate down to the belly, and there's going to be a little arm on the inside called the SHA, the sample handling arm, to manipulate it, take pictures, assess the volume, and then seal it.
That's fantastic. And so there's quite a bit of robotics happening between this part, the bit carousel, and getting it underneath. As we know, it's now underneath. But here's a special guest. We're going to duck down. This is the Mars helicopter.
Yes, Ingenuity.
Mu, this thing is going to be actually tucked up underneath the rover. It was a late addition to this project, but it's probably one of the neatest things on it.
It is pretty amazing. 2,400 RPM that these blades are going to spin in counter directions.
Yeah.
It's a little bit under 4 pounds. It's super light. And yeah, it's going to be the first rotorcraft flight on the surface of Mars. It's spectacular.
And you know what's amazing? It will be taking pictures as well, right?
That's
Look at
right.
that. The blades,
Wow.
these blades turn,
Great
right?
model.
And they turn in opposite directions.
They
I
do.
understand.
They
Yeah.
do.
It will have a camera on it. It'll shoot live or shoot video.
Yes.
That we will then get back. It'll shoot video of the rover as it's doing its work, right?
Yeah, it's spectacular. And look at the clearance. I mean, this rover needs to clear this helicopter after it's deployed.
All right. Well, thank you so much for giving us the tour of the mock-up. It's just like the real one, except for it's not going to Mars. Well, thank you so much. And so by now you may have heard that this Perseverance rover was named by a 7th grader. And it was given that name, which is very special to us. And so we asked Hidden Figures actress Octavia Spencer to tell you why the Perseverance name is more than just a name to us here at NASA.
We are a species of explorers, believers.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard.
We are willing to do the hard things, to overcome the many challenges. This is what brings out the best in us.
We are go for a mission to the moon.
Our path has led to success and to bitter losses.
We come together today to mourn the loss of 7 brave Americans.
Yet, even when faced with tragedy and setbacks, we persevere. We keep striving. We keep believing. From space, we see our planet as a whole. We see the challenges facing it, and we face those challenges together. We will not give up. We challenge convention. We refuse to accept the status quo. The time at hand is hard, but we will persevere. We can still draw hope from the moon and the stars, from space, from exploration. There is a new day beyond the challenges we face now.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans.
10, 9, we have ignition sequence start.
But if rovers are to be the qualities of us as a race, we missed the most important thing.
3, 2,
perseverance.
launch commence. Liftoff. We have liftoff.
We are a species of explorers. We will meet many obstacles on our way to Mars. But as humans, will not give up. We will always persevere.
Our collective perseverance is what has gotten us to this day. And now Mars 2020 is on its 7-month journey to Mars with an anticipated landing date of Perseverance on February 18th, 2021. Now we are joined by Dr. Thomas Zurbuchen, Associate Administrator for Science at NASA. Dr. Z, thank you so much for coming over here.
God, I'm so glad I'm here, and I'm so relieved. You know, we have a space mission, and we're in touch with the spacecraft, you know, and everything is nominal. We're waiting, of course, for the second burn. But not quite there, but we're really close.
Yes. So can you tell us what makes going to Mars incredibly hard?
So there's really 2 pieces that make it hard. The first one is what we're doing today, which is you really need to head in the right direction.
Yeah.
So take it off the Earth and have a lot of energy and head exactly in the right direction, because what you want to make sure is in February, when Mars comes, you want to be right there so you can get captured. The second one, which is the one that's going to make us nervous in February, is to entry, descend, and land. You know, so the Mars atmosphere is almost the worst of all worlds. If it was really thick, you could do what we're doing on Earth, which is go in and with parachutes. Yeah. If there was none of them there, you could do, you know, what we do at the moon. When in Mars, you have to do both on top of each other, which makes it 10 times harder than any of the other 2. And so that's what makes it so hard.
Wow.
You've devoted much of your life to science. And I know you were asked the other day during a news conference, you know, why another rover? And you gave a pretty impassioned response. Why is this rover important in your mind to the work that so many people are doing in science?
So it's really kind of a key of a whole bunch of new research that we're doing that is focused on a question that for thousands of years philosophers have asked, scientists have asked, and we're ready to answer with the tools of science, which is the way to get reliable answers. And that is there life out there? We have, for 20 years, we've learned about the environment at Mars, and we're ready to ask that now. And the way we're doing it is with this rover. So it's really, for the first time in decades, the first astrobiology mission. We're ready for it. Where it's the next step, and of course there's others coming. Dragonfly.
Yeah.
We're already thinking about, and other missions. We want to, of course, go to Enceladus in Europa, and really learn about life there also. So it's an amazing first in that respect.
And whether there's life there or not, that's going to be the answer that we're looking for in these places.
So yeah, exactly.
Yeah, and so we want to do a social media question real
Yeah,
quick,
we
if
have
that's all right with you.
Oh, absolutely.
All right.
We have a question from Twitter. What is the key difference between previous NASA missions, rover missions to Mars, like Spirit, Opportunity, Curiosity, and Perseverance Rover? In what way is Perseverance unique from the previous ones?
So there's a fundamental difference in the approach. And the fundamental difference is that we decided to put the instruments on Perseverance, the best geology instruments on this, so we can find the right samples. And we decided not to put a chemistry lab on it. Guess why? We don't know which one yet. And so what we're doing is we're actually collecting the samples that we're going to bring to the best labs that are available to humanity, which are the labs all over the world. And that's the choice here. And that's, of course, to do that, we need to do another first, which is humanity's first round trip to another planet. And that's what makes it different.
We've got more with the launch operation to go, but real quick, how'd you feel about that launch?
Oh, I loved it. It's like punching a hole in the sky, right?
Yeah.
It's really getting off the cosmic shore, our Earth, into wading out there into the cosmic ocean. I just love it every time it gets me.
All right, very good. Dr. Thomas Zurbuchen, thank you for joining us. We appreciate you being here to explain all the science and the excitement that's coming up.
Thank you so much.
All right.
Appreciate it.
Now we've talked to scientists and engineers, and we have shared highlights of the mission and tech demonstrations that are central to the Perseverance rover. And folks, we have a lot more to share.
Mars Perseverance has been flying in space for more than a half hour now. Let's check back in with Joshua and Mick to recap the flight so far and tell us what's coming up next.
Hey, thanks, Moo. Yeah, as you're seeing on screen there, that is, again, the animation of the Centaur in motion around Earth, in orbit around Earth. And you can see there, like I mentioned, the animation being driven by real telemetry data. Mick, how is the report coming back from the first burn and then currently our coast phase?
So we're hearing from Jesse Gonzalez and the engineering team is that everything so far has been nominal. Centaur's been performing well. All the settling firings have been going great, which is keeping the fuel that's still in the tank where it needs to be as we get ready to come up on main engine start 2 for that second burn, which is very important to get us our velocity and into that transfer orbit to Mars.
Yeah, so that will be up in just a few minutes, but I think we're going to actually send you back out to our main desk to hear. Oh, so sorry, I'm being held. We're going to hang out here. So coming up, so talk about C3, Mick. This is something that we talked about having to do with the energy to leave Earth and go somewhere else. We're talking about having to get to speeds over 25,000 miles per hour. That's Earth's escape velocity.
Yeah, so C3 is basically just the technical term that we use in the aerospace industry to refer to the velocity that we need to get the vehicle where it needs to be. So as you said, we got that little over 2 million pounds of thrust that we left Earth this morning with those mighty 4 solids on the Dominator. I still like that from Tori Bruno. Tori, I'm gonna take that one from Tori. But we got off here and into the park orbit with the proper velocity we needed. And then, of course, this second burn is so important for the velocity we need to get in transfer orbit.
Awesome. So the Dominator punching a hole in the sky, as Dr. Zurbuchen said. So we will send it back out now to the main desk and be back with you in just a minute to catch that second burn. Daryl?
All right. Thank you very much.
Thanks so much, Joshua. Joining us now to talk about how special these missions are is Dr. Michael Watkins. He's the director of the Jet Propulsion Laboratory in California, which planned Perseverance's mission to Mars. That is my home center. Thank you for joining us, Dr. Watkins. So we have so many great questions for you. Why are missions to Mars unique?
But I think they're unique for two ways. And one is just Mars. It's been in our imagination for centuries. It's a place that looks like the Earth. It looks like it could be home to us. It looked like it was once home to to what could have been life. And the fact that we can get there, and we can get there every couple of years, and we can send missions, and we can build on those missions, and you can learn from your mistakes, you can learn from your successes. One of the things I like to joke about is we say Perseverance looks like Curiosity, but the people who built them are the same. They look even more like each other. And so they so a lot of our folks worked on Mars Pathfinder, they worked on Spirit, Opportunity, they worked on Curiosity, and now Perseverance. And that that history, that group of folks, they're just world leaders, and it's why we're successful.
So you oversee the Jet Propulsion Laboratory in California and doing incredibly complex work. Why are these robotic missions so hard?
They're hard because you can't really see what's going on. You can't use your human responses, right? You're used to driving your car and see what's happening, and you turn the wheel. In this case, we've got to tell the rover. We've got to prepare the rover to do a lot of that stuff on its own, right? And so we've got to understand Mars, we've got to understand how the rover works, and we've got to put all that together into a machine that can function more or less without us. Mm-hmm. So we talk to it once a day, and we say, how are you doing? And go over there and do these experiments, and then it's got to do that. So we kind of give it its intention, mm-hmm. but then it's got to do all those activities by itself, and that's a challenge. And the further away from the Earth you get, the harder it is. So you get out to Saturn, you get to Europa, you get beyond, and it becomes harder and harder.
Yeah. Real quick, one question to wrap up. You've been in touch with the folks out at JPL. On air, there was an earthquake that played out. It was a 3.9 magnitude. How is everybody doing? How's your team?
They're doing great. Our view is just Pasadena. It's just the Earth being excited about going to Mars. So it was a very minor earthquake. We have them a lot in California.
Okay.
Maybe it's like hurricanes here or something, but
yeah.
Tropical storms here. But it was a very minor event, and everything's fine. And we are on our way to Mars.
Okay, so a little rumble here in Florida, some rumble in California. Works out great. Mike Watkins, thank you so much. We appreciate you joining us on the broadcast.
My pleasure. Thank you.
Awesome. We will have that conversation with Zena Cardman coming up,
which
I'm super excited about.
That's right.
Yeah. On the other side of the Centaur burn and spacecraft separation. We'll also highlight 6 major technologies that NASA is focusing on over the next decade, including the critical energy needs for such missions. But with that, let's turn our attention to the next operational steps. Joshua, are you there?
Yeah, Moo, we're here and we're excited. We have a fuel pre-start call just coming in. We are getting ready to hear the call for this second burn of that Centaur RL-10 engine. Again, Mick, explain what this second burn is for.
So as we talked earlier, the second burn is really to get us that velocity as we head into that transfer orbit, right? Centaur and Mars 2020 will head into that solar orbit on its way with the proper velocity. We will then get ready to separate Mars 2020 on its way. And I'm hearing that settling is done, and we have main engine start.
There we go. Awesome. And again, that animation there being driven by actual telemetry data coming from that rocket. So that's a phenomenal sign. And again, I think that it's tough with these images. Perspective and scale are so important. This vehicle is in Earth orbit. It's not near anything, so you can't see the acceleration of what's happening right now. But for 8 minutes, it's going to be picking up speed.
Yeah, this is the burn that gets us really moving in the direction we need to go, that fast velocity that we need to get out of our park orbit and head on our way to Mars. Of course, Centaur and Mars 2020 are still together, and as we're hearing, everything is looking nominal on this fire so far. Main engine start was good, and the firing is going well, nominal, as we see in the animation there.
Fantastic. So this is rocket science, and it's not easy. We actually want to bring in now, we have a special guest. This is Dr. Denton Gibson, excuse me. Yes. He is a rocket scientist. His official title is Senior Vehicle Systems Engineer. Denton, how are you doing?
I'm doing well. Thanks for having me.
Yeah, did you enjoy that? Obviously, you got to kind of spectate. A lot of days, you guys sitting on console, you have to kind of focus on your computer, but you got to see this one today.
Oh, yes, and it was a beautiful launch today.
Yeah, nice sunrise. Hey, tell us about your role with LSP. I was not making up things when I said you're a rocket scientist, but what exactly do you do?
So as our role in LSP, as a vehicle system engineer, we are the engineering team lead for a lot of the rockets that we launch our science missions on. And we are responsible for the oversight and insight into these launch vehicles for the NASA.
That's awesome. And I know in the past you've supported a variety of vehicles. Tell us a little bit about the vehicles that you have supported and the ones you're focused on today.
Yeah, so some of the vehicles I supported in the past is the Delta II, which was a long-time workhorse for our science missions, as well as the Pegasus and Taurus / Minotaur C. And right now I've been focused mainly on the Falcon 9 and Falcon Heavy.
Yeah, awesome. So obviously not focused on the Atlas V, but a lot of that experience and the process is the same. I want to take a moment to pause and say Denton's there at Hangar AE. That's the NASA Launch Services Program's hangar. They're very proud of that. We call it the telemetry center of the universe. That's where the data for today is flowing. But I wanted to also ask you, is the process the same for all these vehicles? When we talk about the telemetry and these sort of processes of getting from Earth to Mars, does Falcon 9 experience translate to Atlas, or are they completely separate?
So the overall process for many of these launch vehicles are the same, whereas you ship stages to the launch site and assemble the launch vehicles by stages. So in that sense, they're the same, but there's a lot of differences between the launch vehicles that may change that process a little bit. But in general, the processes are the same.
Yeah, and Joshua, I was going to say, Denton, I worked with Denton quite a bit over the years, and he talks about the different vehicles he's worked on. But Denton is one of my senior vehicle engineers in LSP. And so although he's not totally supporting Atlas V today, he does have experience with Atlas V. And as he said, things are very similar. So using his experience, we're able to train and bring on new generation of engineers. And Denton's been a huge part of that to allow us to grow our bench, if you will, to start working commercial partners.
Yeah, awesome. So Denton, tell us a little bit about kind of what's involved, what goes in behind the scenes, what's the rocket science of going from Earth to Mars, this maneuver to go into solar orbit.
Yeah. So a lot of the things that happen behind the scenes it's a lot of analysis work done by our analysis teams. I mean, it's months and months of analyses that are performed based on the orbit insertion, the performance of the launch vehicle. A lot of modeling and simulations is done to be able to get to this point to where we can transfer from Earth orbit into solar orbit.
Awesome. And obviously you're a rocket scientist. That's for a lot of people, that's like the pinnacle. That's like, hey, I want to be a rocket scientist. So where do you go from here in your career? Because obviously, like, I'm sure there's lots of things that you'd like to go and accomplish.
So, going from here, I mean, one of the coolest things about this job of working in the launch services program is working the launch, right? I mean, who doesn't love a launch, and who doesn't love working launches?
Yeah, we love them. We love them. Excitement this morning, right, Denton? We got to see that's what it's all about.
Of course. So, one of the ideal jobs would be a launch director, because you get to work all the launches. I mean,
Very
how cool
good.
is that?
No, yeah, that's true. And I guess you get to, is it right to say you call the shots, or is it that the buck stops with you, or how would you say that?
I'd say the buck stops with the launch manager. As today we talked, right? Omar Baez is our launch manager for March 2020, and he had to poll the team and make sure everything's ready to go. So the buck does stop with him right there on today's launch. And as Denton says, I think there's a lot of people that would love that job, and Denton's definitely looking at that next step. So I guess we need to give Omar and his assistant launch manager, Tim Dunn, a heads up.
Yeah, there you go. Dr. Gibson.
Dr. Gibson is
Up
on
and
the
coming.
way. Yeah.
Awesome. Well, Dr. Gibson, before we let you go, give us a real quick snapshot. I know you have a mission coming up later this year. What are you working on?
So we're supporting the Crew 1 launch coming up. So we're helping commercial crew out with that one, as well as Sentinel-6 as far as the LSP missions that's coming up later on this year. And so we're excited about that one.
Yeah, a ton going on. Dr. Gibson, appreciate you. Thanks. And I want to take a special moment on the commercial crew note to comment. We've got a big day coming up.
Yes.
Pending weather. There's a tropical system that might kind of get in the mix here, but we have a tropical system that could create some problems. Otherwise, we've got Bob and Doug from Demo 2. They're coming home on August 2nd.
Yes, I was going to say, Joshua, that's important for us also in LSP. Denton was my lead VSE, along with a few others that are in the group that worked that mission with the commercial crew program. And so it's really important for us to be able to support other programs within the agency to make these things happen. As we launch Mars 2020 today, which is another step for us getting humans to Mars, right, is getting humans launched off of Earth soil was a huge step for off of American soil.
Yes,
was a huge step for us.
Yeah, and so talk about that really briefly with LSP. Obviously, Denton there, appreciate him and his contribution, and you working towards commercial crew, but also supporting Artemis, which is also part of that path of getting humans to Mars someday. Artemis is about learning to live on the moon to sustain a presence there with the eyes on Mars. So how is LSP supporting even Artemis?
Yeah, one of the things there is the Gateway program, right? Deep Space Logistics that is working a lot of that. And so LSP is in the works of supporting Gateway and helping them work with the commercial partners that are providing the rockets for those kind of missions that are out there and future things. One of the cool things about working with the Launch Services Program is that we work with all of our commercial partners, SpaceX, United Launch Alliance, Northrop Grumman Space Systems, and of course some up and comings. You may have heard some, right?
It is
like
a growing
Blue Origin.
field. Yeah.
It's definitely a growing field in the aerospace industry, and LSP takes pride in working with those commercial partners to figure out what we can do for NASA and the country.
Awesome. Yeah, it is an exciting time for spaceflight. The commercial spaceflight industry is booming. There's always new things happening. If you keep an eye on the news, you will see new things. We're getting word now that the engine cutoff here should be happening momentarily. Once we see that happen, we'll have roughly, I believe it's 5 minutes until we actually see the spacecraft separation occur. So we're going to stay with you through that, but want to kind of just preview that for you, that hopefully on screen here, you should be seeing that engine cutoff, and that's completely expected. That's a nominal operation.
Nominal operation. We'll hear from Jesse Gonzalez, who's looking at the launch vehicle telemetry and watching the animation there. So let's listen in for Jesse here.
And there's the call, and there's the animation again, modified based on
The
data. So
RL10 shutdown parameters
let's talk
look
about
good.
communication for a minute,
And
Nick,
we're
because
seeing-
it is not an automatic thing to just shoot information at Earth and have that be usable. So how do we go about communicating not only through launch, but on the way to Mars, and then once we're at Mars?
Yeah, so the important thing this morning is when we lifted off from Complex 41 here at Cape Canaveral Air Force Station, we had ground stations that were looking at the launch vehicle and tracked it all the way to provide data. Once we got onto orbit after stage separation, you heard a call out for TDRS, the telemetry network that NASA owns, which, by the way, is also used for the ISS and will be used hopefully for the landing with Doug and them.
Yes.
So getting off the ground today was great because we could deconflict some of that TDRS usage, right? But TDRS is very important for us to be able to get the telemetry from the launch vehicle back down to Earth here. And then, of course, when Mars 2020 separates and it gets on its way to Mars, then the JPL team will take advantage of NASA's Deep Space Network, which has been around for a long time, to be able to transmit commands and data back and forth to the Mars 2020. So it takes a lot of folks to work those, and the TDRS and Deep Space Network are very important to not only the science missions, but human space flight also.
Yeah, and I think the coordination of that is something that people don't get a chance to understand much, because as you said, we're using TDRS for crew return, we use TDRS for space station, and TDRS is not an unlimited resource. We have a good number of TDRS satellites in orbit that help us do these things, but it is a coordinated effort across the globe, because we even have ground stations in Australia, I think.
Yeah.
Where are all of our ground stations even?
We have ground stations everywhere, not only here in America on the West Coast and East Coast, but then you get into South Africa area, Australia, you said. We have several ground stations that catch up different things for missions. But of course, in orbit, TDRS and the Deep Space Network are very important. And as you said, there's not an unlimited amount of resources there in the TDRS network. So we have to coordinate those things within the NASA agency and with our commercial partners when they're used for our launches. And again, that's another part of what NASA does as an agency.
Yeah, so just on that note, kind of thinking about around the world, currently this spacecraft is roughly over the South Indian Ocean. So that's just thinking about how fast we're moving, just the amazing world of spaceflight. It's just hard to put into words sometimes of like, we're literally flying around the Earth and we're already halfway around it. And so I want to talk actually about planetary protection some more. I know we heard about that a little bit from Moo, about how they're working to protect Mars from contamination, so to speak, just putting things there we don't want. And we have to consider that, or ULA has to consider that when they're flying to Mars and delivering the spacecraft.
Yeah, it's a combined team. ULA, JPL, LSP had to look at that for when we get ready for spacecraft separation here in about a minute, right? One of the things we talked earlier is that Centaur and Mars 2020 are on the same path towards Mars right now. So once we separate, Centaur will do a CCAM maneuver, or what we call a contamination and control avoidance maneuver, and then blow down what's left of propellants in its tank. And by doing that, we have now put Centaur on a different track so that it will not intercept Mars or interfere with Mars 2020 at all for approximately the next 50 years.
Yeah.
And that took a lot of work by the JPL team and the launch team to make sure that would happen. So again, another planetary protection maneuver that had to be done.